Hello and welcome back. This is Steve Scully. I'm reading from the instruction manual as it is written in the Cosmos. We are at chapter 4, section C. So we're talking about the fundamental forces, the not so fundamental forces, and this section is on electromagnetism. So we've already discussed electromagnetic fields. Now we're going to look more generally at electromagnetism. All right then. While two fundamental forces is less than four, it is still more than one. We have already discussed how electromagnetic fields are caused by gravity, strongly supporting that electromagnetism is the result of gravity as well. However, this explanation of how gravity causes electromagnetic fields does not explain how electromagnetic waves function. Therefore, in order to demonstrate that electromagnetism, too, is an emergent phenomenon resultant from gravity, it is necessary to delve deeper into understanding what light is. It is said that light is an electromagnetic wave, having an electric field and a magnetic field. This, however, does not provide a fundamental description of what is happening. In order to obtain such a description, it is necessary to account for gravity's role in the process. So just a generic electromagnetic wave propagates in a direction, having a wavelength between the crests of each wave, and a magnetic field orthogonal to an electric field. So the question is, how does gravity create this? In an electromagnetic wave, as shown in figure 24, there is said to be a wave of light propagating in a direction. The wave comprises an electric field portion which fluctuates orthogonally to a magnetic field portion. The wavelength is a measure of the frequency that the fields fluctuate between crests or troughs. As we have been discussing regularly, all things function the same, whether it be a star or an electron or any other system in the infinite cosmos. The same mechanisms are occurring in all systems. Due to a star's mass, these processes occur so slowly that relative to the atoms of which we are composed, we barely ever see a single star in more than 2 stages. In other words, the most we see of a star is essentially before and after a single or a few rapid supernovae at most. However, due to the relative mass of electrons, the observed rate at which they function is distinctly faster, so much faster that we see it as vibratory. For a star, we say it supernovas. For an electron, we say it becomes excited. These are the same process. With electrons, this does not just happen occasionally as supernovae, but is so frequent and rhythmic that their supernovae make up the pixels of reality around us that we see with our eyes. It is from them becoming energized by an outside source where they then supernova and release a sudden burst of relatively higher mass particles, ones that we see as visible light, rather than their basal emissions without an outside energy source by which we see our surroundings. Again and again, seemingly without end, they supernova. We see it as an excited electron because of our relative mass, but the process is the same. This happens because of the expedited passage of time on smaller scales. In other words, even though we see this process as rapid and continuous, it is because we are seeing a vast amount of time pass within the frame of reference of an observer composed of sufficiently small particles where they perceive these excited electrons as supernovae. Essentially, eternity is passing on such a small scale. Their experience would be the same as our own regarding the frequency of observed supernova in the cosmos when looking to these events. It is from this periodic vibratory nature of cycles where the clues of how the electromagnetic spectrum is the result of gravity can be found. This indicates that just like a supernova, there is a non-uniformity to the rate at which particles are emitted across long periods of time from an object. For instance, when a star supernovas, it releases particles in all directions. If we extend this out to a sufficiently large period of time, then this leads to a cyclical process of short bursts of high-density material with intermediary periods of stable, steady, low-energy emissions as represented in Figure 25. So here we see an electron, and then over the course of time, supernovae occur, causing a high-density portion. Here, SN1 through SN4 supernovas are each essentially outwardly propagating high-density gaseous clouds emitted with a particular supernova event. In a three-dimensional representation, we can look at an example of a supernova as shown in Figure 26. So if this were to repetitively occur, there would be wave after wave after wave across larger and larger distances, causing us to then see this repetition. Envisioning electrons pulsing in this matter, we arrive at the high-density regions as shown in Figure 25. The rate at which this occurs is due to the system's relative mass and the degree of energy influx into the system from outside sources. Across a relatively short period of time, the radiation on a given electron stays generally continuous. This causes regularity and rhythm to the process, amounting in a given wavelength to light. The regularity to which this happens can be related to radioactive decay as follows. Within a given class of particles, let's say an octave, they are unable to grow beyond a certain range without merging to become part of a larger system. For example, atoms cannot become larger than the periodic table's upper masses without becoming constituents of larger particles such as planets, and they cannot fuse together in this way without sufficient energy. The same occurs for electrons. As electrons receive radiation, they physically grow in mass just like a star. Dependent on the energy they are receiving, they can act as either a highly stable system, which is lower in mass, or they can approach the upper limits of mass for an electron in the same way as an atom can approach an upper limit. As a result, they supernova at a higher rate, just like radioactive decay increases drastically at higher atomic weights. This rate determines the frequency of the high-density supernova clouds emitted, which ultimately determines the observed frequency of the emitted light as shown in Figure 27. So in the radio wave spectrum, the vibratory supernovae are less frequent, whereas in the higher gamma ray spectrum, they're much more frequent, which leads to what, as we'll discuss, waves of a higher frequency. And in the same way as a supernova cloud does not move as fast as the light emitted by the stable system, nor does the high-density material emitted by repetitive supernovae of an electron travel as fast as its intermediary emissions that occur while it is stable. This is ultimately because larger systems function slower. In the case of high-density material emitted in a supernova, It is of higher mass and thus functions at a slower rate. In the opposite direction, smaller mass particles move faster and faster, up until they appear to be limited at the speed of light. Importantly, light is just a name we ascribe to particles in the infinite scale that we perceive as sufficiently small to interpret large groups of them as, quote, light. It is no different than mass functionally. If we could zoom in sufficiently on a photon, it would look like a galaxy. And just like a galaxy, it would have other particles so small relative to it that their motion would appear as the speed of light, while the zoomed on photon would appear as a motionless galaxy in comparison. Over and over again, this thought experiment can be done to recognize that as particles approach zero mass, their velocity approaches infinite. We will come back to this in a moment. With each supernova, a high-density cloud is emitted, and then lower mass particles emitted by the same object physically flow past the high-density zones as depicted in Figure 28. This image, where the propagating direction is in the x direction, depicts motion of high-density regions from the point of origin. Lower density, faster traveling, low-mass particles then physically flow up and down, above and below the density segments. This occurs because of the gravity of the high-density region particles on the passing mass. As shown, the wave forms from repetitive gravitational influences as the emissions weave between the high-density segments. So gravity, when it's below, pulls it up towards the high-density region, but it's moving faster, and so it throws it above, beyond. But then the next portion grabs it by gravity again and pulls it down again, creating, and then the next portion, creating a wave where we then see it as a wave. And so the distance of separation between these high density segments between the supernova is what produces the frequency. So if these are closer, then the frequency is higher. And that's because if they're closer, the electron itself is more alike to a radioactive element, where because of this energy input, it's vibrating more quickly between supernovae, creating a more close supernova high density region, and so it results in a higher frequency of the wavelength, or vice versa. If it's not supernovaing as fast, if it's less frequent, like a radio wave, then the high density portions are much more spread out, and so that leads to a much more radio wave-like wave. Similarly, while this is related to the electric field, so this one in the y direction, x direction, y direction x is in this image the electric field. While this is related to the electric field, which has been written in the y direction above, the magnetic field propagates orthogonally to the electric field, shown in the z direction of Figure 29. So it's the same idea, just this time it's in the z direction. Mechanically, the electric and magnetic field function very similarly. The difference in direction is relatable to a high pressure and low pressure storm in the same way as charge is. For a high pressure storm, airflow moves from the inside outward but is fed by air moving orthogonally coming from the top of the storm downward. For a low pressure storm, it is the opposite, where air moves inward but then is fed orthogonally upward. In much the same way, when the electric field moves, it has associated with it the orthogonal flow of the magnetic field. As a result of recognition that gravity causes nuclear fusion, radioactive decay, electromagnetic waves, and electromagnetic fields, It is thereby shown that the fundamental forces can be reduced to only gravity. While this may be simpler than 4 fundamental forces, it is not a full simplification, as we have been building on regarding the universe being infinite, a balance between nothing and everything. Even gravity is explicable as an emergent phenomenon within the structure. Section D, Gravity. As we have been repeatedly revisiting, all things function the same. There are ever larger and ever smaller particles of which the infinite universe is composed. Each of these systems function identically, but at different observed time dilations due to the relative state of the observer, meaning what is seen as a star for an observer composed of a first of these ever larger or smaller particles can be observed as anything ranging from a photon to a black hole for a second observer composed of a smaller or larger building block. And then it can be so unnoticed that we do not presently recognize its very existence. When a given system separates from its largest nearest source of energy and moves out towards the apparent vacuum of space, it radiates like a star, for it is a star. This radiation, too, is a star in its own right. As these systems radiate and move away from their source, they receive less energy from the lowering energy density of the environment, and thereby become smaller in mass. They do this until they reach a steady state with their environment, breaking down into smaller and smaller systems. A vacuum effectively acts to dissolve particles into more and more of their constituents. As a result, in precisely the same way as how more and more atoms filling a given volume press against one another, causing a pressure outward, so too do these most unnoticeable of particles filling the volumes of the apparent vacuum press against one another with increasing pressure. As particles break down into smaller systems, their abundance produces an inverse high pressure. In other words, though a vacuum is low pressure when it comes to large systems such as atoms, it is high pressure when it comes to its smallest constituents due to their sheer abundance in a vacuum. The stronger the vacuum, the more abundant and broken down into smaller constituents each particle becomes, leading to higher and higher vacuum pressures on these particles specifically. This directly relates to matter and antimatter, where in this case, the vacuum particle is the equal but opposite mirror to a normal particle, brought about by the deviation from balance. In order to get 3, it must be taken, leaving behind -3. In the same way, in order to get a star, it must come from the perfect balance, leaving behind its opposite vacuum. Vacuum particles, known as antimatter, break apart systems to their greatest capacity based on the degree of vacuum properties and emit these particles due to the relative high pressure these particles have on one another outwardly in exactly the same and yet opposite way, where normal matter combines systems to the greatest degree that they can based on the amount of mass that they have and emit these particles. Ordinary matter radiates large and absorbs small, while antimatter radiates small and absorbs large. When time is reversed, they do the opposite and function as the opposite. These particles, which the vacuum particles of antimatter create, become so small relative to everything that we know, even photons, that their velocity through space approaches infinity. As these particles, in great abundance, sweep across the cosmos in all directions, their physical flow causes gravity. When an object blocks this flow of particles towards a nearby second object, this blockage produces a noticeably non-uniform force distribution on the second object due to the flow of these particles from the first object's direction being partially blocked. The reduced force from the side of the first object causes the second object to move towards the first and vice versa. This is how gravity is caused as a result of a balance between infinity and nothing. This raises the question, when two things are equal, are they really two things? Two suggests separate and distinct. Equality means that they are the same. In other words, that they are one. To put it succinctly, this means that from an analytical perspective, all is one and one is all. This most sharpened reduction of all observations in physics to being the result of all being one is of paramount importance and will be revisited soon. So that's the end of chapter 4 on the fundamental forces. Next chapter is further analysis, which we will go through to basically just go through some more observations before we jump into some more philosophy. And really what this all amounts to philosophically. So thanks for listening. I'll be back in the next video with chapter 5. Thanks.